Good afternoon, students.
Good afternoon, ma'am.
So, we are discussing about practicals. Okay. So, in the last practical, we discussed about how to start with Xilinx ISC, and then after that, we have seen one small program regarding half adder. Okay. So, that was just a basic introduction regarding how to use Xilinx environment. And then after that, now from this practical, we are actually going to start with our practicals. That is the first practical, which is write a VHDL code for half adder as well as full adder and then simulate it. Okay, so that is our first practical. So the aim of our today's practical is to write a program or write a VHDL code for half adder and full adder. Okay, so here we are going to use data flow model for both these circuits. That means we are going to use Boolean expressions for architecture of this both these adder circuitry, that is a full adder as well as half adder. As you know that we can use three types of modeling. One is the data flow modeling, then another one that is a behavioral modeling, and third one that is a structural modeling. In data flow modeling, we use Boolean expressions to write a VHDL code, while in a behavioral modeling, we are using truth tables. Okay, so depending on how is the truth table for that circuitry, we are writing a code. And in structural uh, modeling, we are using different components, and then we are instantiating these components in the architecture of the current circuitry. Okay, so that is a structural modeling. But right now, we are going to consider a data flow modeling for half adder as well as full adder. Okay, so uh, let us start uh, again with a half adder circuitry. Now, though we have discussed that circuitry in the last practical, but still again we are going to simulate it. Write a VHDL code, and after that we will write a test bench for half adder circuitry, and then we are going to simulate it. We are going to verify results of that circuitry, and once we finish half adder circuitry, then we will go for the full adder circuitry. Okay, so can anybody tell me what are the different um, units in a VHDL code? What are the different, or in other words, I can say it as what are the different parts of VHDL code for any circuitry?
Start with the library declaration.
Yes.
After that, entity declaration. In entity, we are declared the input and output ports. After that, architecture declaration.
Yes. Okay. So we are whenever we are writing VHDL code, then first we declare library. So we are including the libraries, standard libraries there, and also we are using adding packages. Okay. So depending on the requirement, we are adding packages to that uh, program. Okay. After that, we are writing or declaring entity. In entity declaration, we are declaring the ports in that circuit, okay, or that unit, whatever we are designing. So input ports as well as output ports, then type of that ports that we are declaring there. So that is the entity declaration. And in the architecture, that is the main part of this program. So there we are declaring or stating how that circuit is going to behave. Okay, so the main part which will be there in a architecture, which is going to decide whether that circuit how that circuit is going to behave, how we are going to get the output. Okay, so that means we are assigning certain expressions to the output variables, and then from that we are uh, verifying whether the circuit is operating properly or not. Okay, so now uh, let us start with the half adder circuit. Okay, so I'll share my screen. So now what is the first step? We have to click on the icon of Xilinx ISC. So here you can see this is the icon for Xilinx ISC. Click on that and open a okay. So now once you open this, you click on file, okay, then click on project and you will get a new window that is new project wizard. Okay, so you can write down these steps so that whenever you are going to use this software, that time that will be easier. So first of all, write down first step. Okay, so write down first step, click on ISC, that is Xilinx ISC icon. Okay, then once you open, okay, click on file. After that, new project, select new project from file menu and then you will get a new window that is new project wizard. Okay, so now give the name to this project. So here I will give the name that is half underscore adder 1. Okay, so whatever name that you want, that you can give here. So I'm giving the name that is half underscore adder 1. Okay, now choose the location. So here you can choose from this browse menu, you can choose the location. So I have selected it as a C colon slash A slash VIP. That means I have created a folder of my name in a folder which is available at C drive. Okay, so there I am going to save this program. Okay, so that is a C colon. Okay, so you can browse the location for the where you want to save this program. Okay, once you type the name, then go to the next, click on next, and now here you have to select property name. So here that is a by default it will take as a value that I have already told. Then evaluation development board, that is a non specified. Then product category all, and here now family, that you have these many options. Okay, so out of that select Spartan 3E. Okay, so here now where you will need to select at the family of, now what is this? This is the FPGA family. Okay, so FPGA board that are available, so that from that you are going to select a certain family. So we are selecting Spartan 3E. Okay, Spartan 3E, that is related with the logical circuits. Okay, so here we are selecting this Spartan 3E and then device. Okay, so device you can select any one of this. Okay, which is available at your laboratory. So I'll select this XC3S500E. Okay, so that is the device that I am selecting. Okay, mostly if when you see this FPGA kit, then you will find that on the FPGA the number is specified. Okay, so तुमच्या लॅब मध्ये जे कुठलं किट अवेलेबल असेल त्याच्याप्रमाणे तो जो नंबर त्याच्यावरती अवेलेबल आहे तो सिलेक्ट करायचा. ओके, when you are actually using or implementing this circuit on a FPGA. Now just we are simulating this circuitry. So I have just selected this device. Okay, then after that package, that is a VQ 100, or you can So we'll select this BQ100. Speed is a -4. Okay. And then select, remember that you have to select this top level source type as a HDL. Okay. So that is a default HDL. So that we have selected. Then synthesis tool, that is a XST, which is a VHDL or Verilog. Then simulator, iSim. And after that, you can select a preferred language. Okay, so now we are preferred language. This could be VHDL or Verilog. Okay, I am repeating the same whatever we have discussed in an earlier practical, but still I am discussing this. You can take notes how I am clicking on the options. Okay, so त्याचे तुम्ही नोट्स लिहून ठेवा, म्हणजे जेव्हा तुम्ही प्रॅक्टिकल्स कराल तेव्हा तुम्हाला इझी जाईल. ओके, सो आता इथे काय करायचं, प्रिफर्ड लँग्वेज सिलेक्ट VHDL. ओके, now select this property specification in project file, select store all values, then manual compile order, deselect it. Okay, no need to select this. And then okay, enable message filtering, that also disabled. Okay, go for the next. Okay, so here the project summary will be displayed. Okay, in this new window which we have opened, that is a new project wizard. So here you can see that all the summary that will be present. Okay, click on finish. Okay, once you finish this, then you will find that here at this hierarchy, you will get one icon which is stating the name whatever you have given to this project, that is half adder, half underscore adder one, that I have given the name. Okay, right click on that and then click on new source. Okay, so now we are going to write a VHDL code for half adder. So here select VHDL module. Okay, so that is the source type that we are selecting is a VHDL module, and give the name to this file. Okay, and that will be by default, it will be taken for the entity. Okay, so we'll give the name as a HA1. Okay, that is a half adder one that I have given the name to this. Okay, now what is the location for this source? That is nothing but the location of where we have stored the project. ओके, सो हाफ ॲडर वन हा जो काही आपला प्रोजेक्ट आहे तो कुठल्या लोकेशनला स्टोअर केला असेल त्याच लोकेशनला आपली ही सोर्सची फाईल पण सेव्ह करायची आहे. ओके, सो नाव क्लिक ऑन नेक्स्ट. Now here when you click on this, now you will again find that there will be one window open which will be for defining module. Okay, so you will find that there will be entity name, so that is a HA1 जे आपण सोर्सला दिलं तेच नेम तुम्हाला इथं पण दिसेल. So that is a, and for architecture it is by default taken the name that is a behavioral. Okay, so you can change this. We will give the name as a data underscore flow. Okay, so as we are going for the data flow modeling, so I will give the name to this model, this architecture as a data flow. Okay, now we have to here specify the ports. Okay, so whenever you are specifying this ports, port names here, that time only you are declaring the entity. म्हणजे आता इथपर्यंत तुम्ही जेव्हा पोर्ट नेम्स जेव्हा डिक्लेअर कराल त्याच वेळेला तुमची एंटिटी पण कम्प्लिटली डिक्लेअर होऊन जाईल. सो व्हॉट आर द डिफरंट पोर्ट्स इन हाफ ॲडर? How many input ports are there and how many output ports are there? Arpita?
Two.
Hello, Arpita. Abhishek? Hello, Abhishek. How many input ports are there for half adder? 2. How many output ports are there? 2. How many input ports are there for output? 2. How many input ports are there for output? 2. How many output ports are there for input? 2. How many output ports are there for output? 2. How many input ports are there for output? 2. How many output ports are there for input? 2. How many output ports are there for output? 2. How many input ports are there for output? 2. How many output ports are there for input? 2. How many output ports are there for output? 2. How many input ports are there for output? 2. How many output ports are there for output? 2. How many output ports are there for output? 2. How many output ports are there for output? 2. How many output ports are there for output? 2. How many output ports are there for output? 2. How many output ports are there for output? 2. How many output ports are there for output? 2. How many output ports are there for outp Akshay, Akshay, Pallavi.
Yes, ma'am.
Okay, how many input ports are there for half adder? Snehal?
A and B.
Yes, ma'am.
Yes. There are two input ports, A, let us say as A and B. Okay. This is a single bit, so no need to select this bus. Okay. Now, how many output ports are there? Shilpa? Seriously?
Two output port.
Two output ports. Yes. So, let us say sum, which is the output port, and carry. Okay. So, I'll give name to this as a C out. That is again a output port. So what we have done, we have given the port name and then we have decided direction of that port. So A and B, these are the two input ports. So the direction is in, and S and C out, these are the two output ports. So the direction, that is a out. Okay. So then click on next. So here you will find a summary of your source, and then you will find that architecture name, then entity name, then port definition. So what are the different ports which are available in your entity, that will be summarized in this window. Okay. Once you check it, click on finish. Okay. So click on finish, and then you will get this window. Okay. So here you can write your architecture. So when you say this, you will find that here it will be the name of the who is designing this, then after that whatever is the module name, then project name. Okay. तुम्ही ती कधी create करताय, what is the timing, so that all will be present in this. Okay. And all that will be in the comments section. Okay. So now after that, this library, okay. So this library IEEE, that will be by default, it will be added to this VHDL program, as well as this package, that is IEEE.std underscore logic underscore 1164. That will be also by default get added. Okay. Then after that, excuse, excuse, after that you will find a entity. Okay. आता जे काही तुम्ही पोर्ट नेम्स आणि त्याचे डायरेक्शन डिसाइड केली होती, त्याच्याप्रमाणे तुम्हाला इथं एनटीटी मध्ये पोर्ट्स डिक्लेअर झालेले दिसतील. ठीक आहे. सो एनटीटी HA1 is okay. So check the syntax here. So as per how we are writing the program, so depending on that you will get this जनरेटेड. म्हणजे जेव्हा तुम्ही VHDL प्रोग्राम लिहिताय त्यावेळेस तुम्हाला एनटीटी ही वेगळी डिक्लेअर करायची गरज नाहीये, म्हणजे तुम्हाला ते प्रोग्रामिंग करायची गरज नाहीये. तुम्ही डायरेक्शन मध्ये जस्ट स्पेसिफाय केलात की आणि पोर्ट नेम्स दिले की तुमचे एनटीटी डिक्लेअर होऊन जाईल. ओके. अँड आफ्टर दॅट यू हॅव टू राईट अ आर्किटेक्चर. ओके. आता इथे मात्र तुम्हाला काही मिळणार नाही, इथे तुम्हाला तुमचं सर्किट कसं बिहेव करायला पाहिजे त्याच्याप्रमाणे तुम्हाला प्रोग्रामिंग करायला लागेल. ओके. So this is the architecture data flow of the entity HA1. Okay. Is, and then it is a begin. Okay. So now what statement should be there? काय लिहायला पाहिजे मग आपल्याला आता आपण डेटा फ्लो मॉडेलिंग करतोय.
S is equal to A XOR B.
ओके. आता इथे आपल्याला इक्वल टू हे साइन आपण कुठे बुलियन एक्सप्रेशन मध्ये वापरतो, पण आता इथे आपल्याला काय वापरलं पाहिजे, सिंटॅक्स काय, आपण असाइनमेंट करणार आहे त्यामुळे लेस दॅन ऑर इक्वल. ओके,
Less than or equal.
लेस दॅन इक्वल टू. ओके, and then A XOR, this is the keyword that is used for XORing B. ओके, सेमिकोलॉन. ठीक आहे, हे काय झालं, एस साठीचं सम साठीचं एक्सप्रेशन झालं. आणि सी आउट साठीचं काय एक्सप्रेशन येणार आहे, सी आउट दॅट इज अगेन असाइन A. What is the expression?
And B.
A and B. Okay, semicolon. Don't forget to give semicolon. जर तुम्ही semicolon नाही दिलात, okay, I'll show you. मी इथे नाही semicolon दिला. ठीक आहे. Okay, now end of this data flow. ठीक आहे. Now save this program. आणि तुमचा इथे प्रोग्राम फिनिश कंप्लीट झालेला आहे. So save this. Okay, now you will find that there is a error. Okay, near end. Okay, आता ही एरर का आली आहे, कारण आपण इथे सेमिकोलॉन नाही दिलेला. ओके, सो सेमिकोलॉन, I'll again save this. Now you will see that there is no any error. Okay, so I'll check the syntax. Okay, syntax is correct. So check, let us check RTL schematic. Okay, so start with the schematic of the top level block. So ओके, इथे तुम्हाला काय मिळेल, त्याचं स्कीमॅटिक मिळेल. आणि जर याच्यावरती तुम्ही डबल क्लिक केलं तर तुम्हाला अजून पण त्याचं इनसाइड सर्किटरी यू कॅन ऑब्झर्व. ओके, सो दिस इज अ सर्किटरी ऑफ अ हाफ adder. Okay, RTL schematic of half adder. Okay, you can also go for view technology schematic. So again, we are selecting the option that is a start with a schematic of the top level block and then okay. Now what is difference in the earlier circuit and this circuit? Can you observe? Okay, I'll show you this circuit. This is a technology schematic and another one that is a RTL schematic. Okay, I'll just click on this. Okay, this is a inside circuitry. Okay, inside that block, this is a AND gate. Okay, and inside this block, it is a XOR gate. Okay, now what is the difference between RTL schematic and technology schematic? काय ऑब्झर्व करताय तुम्ही?
मॅम RTL मध्ये सगळे गेट, बेसिक गेट म्हणजे आपल्या ज्या कंपोनंट मध्ये जे बेसिक म्हणजे हे यूज करतो आपण इक्वेशन, त्याच्यावरनं त्यांनी बेसिक गेटची डायग्राम बनवली.
ओके, सो RTL मध्ये काय आहे की तिथे तुमचं जे काही रेजिस्टर ट्रान्सफर लॉजिक आहे, जे त्याच्याप्रमाणे तुमची सर्किटरी आहे. ओके, इनपुट पोर्ट पासून तुमचं गेट पर्यंत कसं येणार आहे आणि गेट पासून परत आउटपुटला कसं जाणार आहे, त्याची जे काही स्कीमॅटिक आहे ते तुम्हाला RTL लॉजिक मध्ये दिसेल. इथे तुम्हाला काय दिसतं की बिसाइड्स दिस गेट्स, ओके, म्हणजे याच्या आतमध्ये गेटच आहे, पण बिसाइड्स दिस गेट यू कॅन सी हिअर बफर्स. ओके, you can see there are input buffers as well as output buffers, okay, that are not available in a RTL logic. RTL schematic मध्ये तुम्हाला ते नाही ऑब्झर्व होणार, ते इथे कुठे अवेलेबल आहेत तर टेक्नॉलॉजी स्कीमॅटिक मध्ये आहे. कारण इथं काय होणार आहे की तुमच्या इनपुट पिन पासूनचं जे काही इनपुट आहे ते तुमच्या गेटला, ज्या पिनला म्हणजे इनपुट पिनला डायरेक्टली नाही जाते, तर ते बफर होतात. ओके, सो दॅट इज अ technology schematic. Okay, then let us generate post synthesis report. Okay, so that is also, so almost we have done synthesized this code. Okay, so now click on half adder. Okay, right click on that. Okay, now before that, what we have done, we have written VHDL code, we have checked whether it is correct or not. ओके, त्याच्यावरून आपण त्याची आरटीएल स्कीमॅटिक पण बघितली, टेक्नॉलॉजी स्कीमॅटिक पण बघितलं. ओके, हे सगळं केलं, पण आता त्याच्यानंतर ऍक्च्युअली ते सर्किट प्रॉपरली वर्क होतंय की नाही हे आपल्याला बघायचं. ओके, म्हणजेच आपल्याला आधी ते सर्किट टेस्ट करून बघायचे की वेदर इट इज वर्किंग प्रॉपरली ऑर नॉट. ते प्रत्येक इनपुट दिल्यानंतर मला त्याचप्रमाणे आउटपुट जसं एक्सपेक्टेड आहे तसंच आउटपुट मिळतंय की काही वेगळं मिळतंय हे बघण्यासाठी मला काय करायला लागेल, तर ते मला टेस्ट करायला लागेल. ओके, so whenever you are checking any IC in a lab, what you give different inputs, okay, to that IC, and then depending on that you check whether it is giving correct output or not. म्हणजे जर तुमचं NAND गेटचा IC असेल तर तुम्ही NAND गेटच्या इनपुट पिन्सना तुम्ही इनपुट देऊन बघता. ओके, आणि त्याच्याप्रमाणे तुमचं आउटपुट मिळतंय की नाही, म्हणजे तुमचं ऍक्च्युअली कसं यायला पाहिजे ते येतंय की नाही बघता, आणि मग डिसाईड करता की अरे हा आयसी प्रॉपरली वर्क होतो, किंवा अरे हा नाही होते आणि याचे रिझल्ट प्रॉपरली येत नाहीयेत. बरोबर आहे, त्याच्याप्रमाणेच आता आपण इथे काय करणार आहे की सिम्युलेट करून बघणार आहे की आपलं आउटपुट प्रॉपरली येतंय की नाही. आणि त्याच्यासाठी काय करणार, मग आपण टेस्ट बेंच घेतो. टेस्ट बेंच म्हणजे काय आहे की जसं मी आधीच क्लासमध्ये डिस्कस केलं की that is a nothing but a small VHDL code which decides or which tests your VHDL code for the जो काही तुमचा VHDL कोड तुम्ही लिहिलाय ज्या एंटिटी साठी लिहिलाय ते चेक करतो, टेस्ट करतो. ओके, सो आता आपल्याला या हाफ ॲडर साठी चेक करायचंय. सो क्लिक ऑन न्यू सोर्स. ओके, नाव हिअर सिलेक्ट VHDL टेस्ट बेंच. ओके, आता आपण नवीन सोर्स लिहितोय, पण आता आपण काय करतो, कोड लिहित नाहीये, म्हणजे VHDL मॉड्यूल लिहित नाहीये, तर आपण टेस्ट बेंच लिहिणार आहे. सो VHDL टेस्ट बेंच. ओके, and now I will give a name to this test bench as a, okay, HA1. Okay, I'll write it in a capital manner. That is not going to make a difference, कारण तुम्हाला माहिती आहे की VHDL is a case insensitive, त्यामुळे मी अप्पर केस मध्ये लिहिलं काय आणि लोअर केस मध्ये लिहिलं काय काही फरक पडणार नाही. बट स्टील माझ्या समाधानासाठी की मला हे छान दिसतंय असं वाटण्यासाठी मी अप्पर केस मध्ये लिहिते. ओके, and then I'll give the name to this test bench as a HA1 underscore TB, so which will be deciding that this is a test bench. Okay, now again location for this test bench will be the same where we have written the VHDL code, म्हणजे जिथे आपला प्रोजेक्ट सेव्ह आहे तिथेच आपण हा टेस्ट बेंच पण सेव्ह करणार आहे. सो सेम लोकेशन इज सिलेक्टेड अँड देन क्लिक ऑन नेक्स्ट. ओके, आता इथे आपण कुठल्या सोर्सला असोसिएट करणार आहे, तर HA1 या सोर्सला असोसिएट करणार आहे. सो इट इज अ HA1 that is selected. Click on next. Okay, so here this is a VHDL test bench. For the name for this source name, that is a HA1 underscore TB, and then which is associated with the VHDL code of HA1. Okay, click on finish, and then you will get this test bench file open. Okay, so here you can see that this is same similar to that of the code which we are written already. Okay, so here this library that will get included, and after that there will be entity. Okay, so entity HA1 underscore TB is off. Okay, now here we are using the component that we have discussed earlier or that we have designed earlier. So here there is no need to declare a ports. Okay, so we are directly going for the architecture. So here architecture behavior of HA1 TB. So याच्या ज्या जे काही टेस्ट बेंच आहे त्याच्यासाठीचं आर्किटेक्चर. Okay, I have not changed the name for this. Okay, so it will be behavior. Okay, now we are instantiating a component here. म्हणजे component declare करणार आहे आपण इथे. So component कुठला component तर HA1, म्हणजे आपण हाफ ॲडर इथे कॉल करतोय. So तो component HA1 ports that will be declared here. जे काही ज्या हाफ ॲडर मधले जे काही पोर्ट्स आहेत that need to be declared here. So A, B, that are the input ports which are of the type std underscore logic. Okay, now you must have observed that we have not specified this port type. Okay, direction that we specified, but this type that we have not specified anywhere in the program. But by default, it will take as a std underscore logic if it is a bit type, and it will take it as a, that means if it is a single bit, and it will take it as a, if it is a bus, then it will take it as a std underscore logic underscore vector. Okay, so that all ports that are declared here already, whenever you are going for the test bench associated with that entity that you have already written. So this will be okay. Now initially input signals that will have the value 0. Okay, so that is also specified here. We have not done any changes till now in this code. Okay, so इथपर्यंत inputs काय असणार आहेत, initial value that will assign as a 0. That means actually it will reset that circuit. ते जे काही तुम्ही डिझाईन करता त्याला काय करणार आहे, रिसेट करणार आहे, म्हणजे म्हणून मग इनिशियल व्हॅल्यूज त्याच्या सिग्नलच्या सगळ्या इनपुट सिग्नलच्या काय होतील, 0 होतील. आणि त्याच्यानंतरच मग आपल्याला डिसाईड करता येईल, कारण आधी इनिशियल व्हॅल्यूज 0 होत्या, त्याच्यामुळे त्याच्या पुढे आउटपुट मध्ये जे काही चेंजेस होणार आहे त्याप्रमाणे आपल्याला डिसाईड करता येईल की वेदर इट इज वर्किंग प्रॉपरली ऑर नॉट. सो दॅट इज असाइन्ड हियर. देन आउटपुट्स दॅट आर अगेन नाउ प्रत्येक जे काही तुमचे पोर्ट्स आहेत ते काय केलं तिथे ऍज अ सिग्नल असाइनमेंट केलं, म्हणजे प्रत्येक ठिकाणी इथे आपण काय करतो, सिग्नल घेतोय. सो आउटपुट सिग्नल दॅट इज एस अँड सी आउट दॅट आर अगेन ऑफ द एसटीडी अंडरस्कोर लॉजिक. ओके, त्याच्यानंतर इथे तुम्हाला काय दिसेल की इथे कॉन्स्टंट आणि क्लॉक पिरियड टाइम, त्याचा टाइम दिलेला आहे जो 10 नॅनोसेकंद. ओके, सो दॅट मीन्स इट विल बाय डिफॉल्ट असाइन सर्टन क्लॉक हियर. ओके, जी तुम्ही चेंज करू शकता, पण तुमच्या सर्किटमध्ये आता तुम्हाला गरज नाहीये क्लॉकची, म्हणून याला कमेंट करून टाकायचं. सो कमेंट साठीच 2 डॅश. ओके, तर तिथे करून टाका. आणि त्याच्यानंतर काय करायचंय, आपण ऍक्च्युली स्टार्ट करतोय या आर्किटेक्चरला. सो बिगिन, म्हणजे इथे आपण काय केलं, आर्किटेक्चर मधले जे काही कंपोनंट आहे ते डिक्लेअर करून घेतलं, जे आपल्याला बिगिनच्या आधी करावं लागतं. जे पोर्ट्स डिक्लेअर दुसरे करायचे असतील तर ते करून घेतलेले आहेत. आणि त्याच्यानंतर आपण काय करतो की जे कंपोनंट आपण घेतलाय त्याचे कनेक्शन आता करायचे. ओके, इन्स्टन्शिएट करतो जे युनिट अंडर टेस्ट आहे त्याचा, जे टेस्ट करणार आहे सर्किट त्याचं. सो फॉर दॅट we have taken the name for this as a UUT, that is a unit under test, and then we are mapping the ports of this unit with the half adders ports. Okay, so HA1, then port map. Okay, so we'll give the same name as that of the ports of this HA1. So A is as A, B that is a B. So assignment सगळे port map करून घेतलेले आहेत. Okay, now check the symbol here. Okay, it is a equal to and greater than for this assignment. Okay, त्याच्यानंतर परत तुम्हाला दिसेल की इथे क्लॉक प्रोसेस डेफिनेशन आहे. आपल्याला याची गरज नाही, कारण आपण आता इथे क्लॉक वापरतच नाही. त्यामुळे हे जे सगळं आहे त्याला कमेंट करून टाका, किंवा एक तर ते तुम्ही डिलीट करू शकता. पण ठीक आहे, आपण इथेच ठेवूयात त्याला, आणि त्याला मी कमेंट करते फक्त. ओके, सो ही जी सगळी प्रोसेस आहे क्लॉक साठीची ती कमेंट केली आहे. ओके, that we are not going to use in this program, so that is why we have commented it. Okay, after that now actually we are going to stimulus process. म्हणजेच आपण काय करणार आहे की जे काही आपले इनपुट आहे त्याला आपण काहीतरी वेगळ्या वेगळ्या व्हॅल्यूज देणार आहे, आणि त्याच्याप्रमाणे आपल्याला मग आउटपुट चेक करता येईल. ठीक आहे, सो फर्स्ट ऑफ ऑल लेट अस होल्ड दिस रिसेट व्हॅल्यू, म्हणजे जे काही ए आणि बी साठीच्या ज्या व्हॅल्यूज आहेत त्या आपण काय करतो, that we are assigning it as a 0 0. So we are resetting all the circuitry for 100 nanosecond. So for that we have this statement that is a wait for 100 nanosecond. Okay, so remember that here 100 nanosecond, here this there should be a space in between this liberal. Okay, so we have given this space, and after that we are assigning value. Okay, so A will be now assign. Okay, आता इथे आपण constant देतो. So for the constant, let us take a single quote. Okay, single quote, and then I'll assign the value for A as a 1. Okay, semicolon, and for B it is 0. Okay, and then semicolon. Okay, now again I want to wait for 100 nanosecond. Okay, so that you can change this timing. So I'll copy this Okay, and then paste it here. I'll make it as for 100 nanosecond. Now I'll change A to 0 and B to 1. Okay, then after that again I'll make this A is equal to 1 and B is equal to 1. Okay, I have not taken here A equal to 0 and B equal to 0 because already whenever we are resetting that, we can check their result for sum and carry. Okay, so now this is clock signal that is not required. Again I'll comment it and then wait. Okay, so that means whatever are the last values that will be restored. Okay, so that is for wait. In end of this process, end of the architecture, and then end of this, that means here we have concluded this test bench. Save this. Okay, and once you save it, go for now simulation. Okay, here you can see that there are two options. One is the implementation and another one that is a simulation. Select simulation. Okay, and then select this test bench. Okay, ज्याच्यासाठी तुम्ही सिम्युलेट करताय तो टेस्ट बेंच सिलेक्ट करा. Once you select this, here you will find that in this window you can see that there will be iSim simulator option that will be there. Okay, click on, okay, expand that and then click on, double click on behavioral check syntax. Okay, if your code is correct, then it will mark as a check it, otherwise it will be wrong, then error will be generated. Okay, now once this syntax has been checked, click on simulate. Okay, new window that will open, which will show you the waveforms. Now here if you observe, you will see that same type of output that is observing, but if you look clearly here, it is in a milliseconds. Okay, इथलं जे काही unit आहे, whatever unit that is displayed over here, that is in a millisecond, but we have taken it as in nanoseconds. So we need to we need to zoom this to full view so that you can get a this type of waveform. Okay, now here we have resetted the circuitry for 100 nanoseconds. So till 100 nanosecond, okay, here you can see that inputs A and B, okay, both are 0 0. तुम्ही जर इथे दोन या दोन व्हॅल्यूज मध्ये डिफरन्शिएट केलं, whenever you are differentiating this is a 0 logic level and this is a 1 logic level. Okay, so here you can see that A is 0, B is 0, sum is also 0, carry is also 0. Okay, so if I click on this, okay, so here you can see that sum A is 0, B is 0, sum 0, C out 0. Okay, next I have changed the values to A equal to 1, B equal to 0, then sum will be equal to 1 and carry equal to 0. Okay, so here you can see that these values are A 1, B 0, sum 1, carry 0. Okay, then next value, that is a A0, B1, sum 1, carry 0. Okay, and the last, that is a A1, B1, sum 0 and carry 0. Okay, so that means as per the truth table we are getting the result. So whatever we have designed, that is correct. Okay, म्हणजे तुम्ही जो काही code लिहिलाय, whatever code you have written, that is a correct code because all the results that you are getting correctly. Okay, so this is about the half adder simulation. Okay, anyone has doubt about this?
No, ma'am, no doubt.
Now everyone got how to check test bench? Okay, whatever we were discussing in the class. Okay, that means in a lecture time, there we were writing the test bench for different circuitry. Okay, so we have still going to continue about another circuitry, but here all of you got how to check this. Yesterday I was saying about check up different waveforms, okay, and then check whether it is correct or not. So how we have checked here, we have clicked on this and then you can see that we are getting the proper result. Okay, so this is a half adder circuit. Okay. Now let us move towards another circuitry. Anyone has doubt?
No, ma'am.
Okay. Let us proceed.
Yes, ma'am.
Yes, ma'am.
Okay. So we'll go for the another circuitry, that is a full adder. Okay, I'll close all these. And now I'll click here 5. Okay. Now new project. So I'm going to write now new project. I'll give the name to this full as a FA. Okay. I'll give underscore VAP. So that is the name for my project. Okay, I'll give this as a FA1 as a underscore VAP. Okay. Location, check the location. Wherever you want to store this, you can browse it from this plus and then save there. Okay, I want to save it in the VIP folder itself, so I will take it there. Now remember that make this top level source type. Okay, that should be HDL only. Okay. So if you go for the schematic, then it will not be correct. Okay, because we are writing now VHDL code, so that means we are using hardware description language. So select this top level source type, that is a HDL. Then go for next. Okay. So here now by default it will take all the other values. So just make sure that you have selected family, that is a Spartan 3. Okay, and then we are selecting this as a XC3S500E, that is the device. Okay, then preferred language, that we have selected as a VHDL. Okay, and all other settings that we will keep as it is, which we have taken for the half adder. We'll go for the next. Okay, here you will observe a summary of whatever is your project. Okay, click on finish. Now here you will get the your project. Okay, so right click on that project, click on new source. Okay, and after that select VHDL model. Okay, then once you select VHDL model, give the name to this. So I'll give this as a FA. Okay, and this is a full adder. Okay, or I'll write it as a full, as it's a full underscore adder. Okay, then location, check the location where you want to save, and then next. Okay, I'll give the name to architecture as a data flow. Okay. Okay, now tell me how many ports are there in full adder? How many input ports and how many output
Three
ports?
input
Three
ports.
input ports. Okay, so let us give the name A, B, and C in. These are the three input ports. Okay, again we are considering a single bit adder, so there will not be the requirement to select this bus because we are selecting a single bit. Okay, then how many output ports are there?
Two output ports, sum and carry.
Okay, I'll give the name as sum itself. Okay, which is a output port. So directions I will select as a output, and then C out, that is the carry. Okay, so it is again direction, that is a out. Okay, okay, all ports that we have defined here. Anything remaining? All input ports and output ports are declared here.
Yes, ma'am.
Yes. Okay, let us proceed. So click on next. Okay, you will find a summary over here. So all the input ports as well as output ports are present here. So you can check for the entity name as well as architecture name. Okay. So then click on finish, and then you will get this window. So here now you need to write a code. So check for the library declaration. So library that is declared here. Then check entity. Okay, check whether all the ports are present. Okay, by default it will come. जे काही तुम्ही तिथे assign करणार आहे ते सगळं इथे येणारच आहे. So A, B, and C, these are the input ports which are of the type std underscore logic, and sum and out, these are the output ports, so which are of the type std underscore logic. Okay, and now we need to write a architecture. So architecture data flow of full adder is begin. Okay, now what will be statement here? Rahul, what are the Boolean expressions for sum and out carry out for full adder? Sum is equal to, that means we are going to assign A,
XOR B XOR C.
B XOR C in. Okay, then semicolon, then C out, that is assigned to, what is the statement here? A and B, or A and C in, or B and C in. Is it correct? Yes or no?
Oh,
Yes?
Yes, ma'am, it is correct.
Okay. So now what we need to do, now this is the end of this architecture. So end of data flow, save this. There is no error, you can find it here. So let us synthesize this. So let us again check the syntax though. Okay, so the syntax is correct. Now let us click on RTL schematic. So start with the schematic of the top level block. So this block diagram that you can see, and if you click on this, you will find this circuit diagram. Okay, so here also you can see all these circuits. Okay, or similarly you can go for the technology schematic. So this is a technology schematic for this circuit. Okay, it is generate post synthesis report. Okay, so that is also correct. So now we have completed the synthesizing of this full adder VHDL code. Okay, now let us write a test bench, because now the code is correct. So next step, that is we are going to check whether the output is going to come correctly or not. Okay, so for that we'll click on this project name, that is a FA1 underscore VFE. Right click on that and select new source. Okay, now what we need to select here, we need to write a test bench. So from this source type, we are going to select VHDL test bench. Okay, give the name to this. So FA underscore TB. Okay. So this is the name that I am going to give this to test bench. Then location, again select the same as that of the project location. Click on next. Now this test bench will be associated to the entity that is a full underscore adder. Okay, so we are going to check, select that. Okay, now here you have only one entity that is associated with this project right now. But if you have different entities, so depending on if you want to check for the small model only, okay, so you can select that associated source only here, and from that you can check it. Okay, but now we have only one entity here, so we are going to select that. So then click on next. Okay, so this is the summary that will be displayed. Click on finish. Okay. Now this is the library declaration. Then entity here again we are using the full underscore adder, that component here. So no ports are declared in the entity, but their component is declared in the architecture. Okay, so here architecture behavior of FA underscore TB is, so here it is a component that is a full adder, then port. So all the ports that are declared for this component and end of this component. Then after that, what we have done, we have resetted this design. So all the signals, input signals that we have set to 0. Okay. So A, B and C that is assigned to the value that is a 0. Okay. So these are the variables, actually these signals that are the variables. So we have assigned all these variables as a 0. Okay, I forgot to tell you that here these are the variables. Okay, they are going to change this its value instantly. Okay? So the assignment operator used here, that is a colon equal to. Okay, and whenever we are using a boolean expression, okay, that time we are using less than equal to. Okay, so इथे काय होणार आहे, तुमचे ते इन्स्टन्स चेंज होतात, त्याच्यासाठी आपण हे जे काही आहे ऑपरेटर तो आपण कोलन इक्वल टू यूज करतो. ओके, outputs signals that are also assigned here, and then we are not going to use this clock, so comment it. Then ports are mapped here. You can check all the ports. Full adder port map, that is a equal assigned to A, B to B, C in to C in, sum to sum, and C out to C out. Okay. Now this is the generated test bench program. Okay, जो काही तुम्ही असोसिएट केला होता तुमची एंटिटी जी काही आहे त्याच्या तो सोर्स आहे त्याच्यातून हा बाय डिफॉल्ट जनरेट झालाय. ओके, don't change this. Okay, otherwise if you give the scene is assigned to B, then it will take the wrong, or it will give the wrong result. So these are the port maps. Then we are going to comment this process because we don't need this in this program. So this is commented. Okay, then actual stimulus process. Now we are going to assign different inputs to each of the A, that is assigned to 1. B 0 and C in I'll take it at the downs, another line. Okay, so the first instantiation, that is I have assigned value 1 to A, 0 to B, and 0 to C. That means now my combination is A is equal to 1, B is equal to 0, C is equal to 0. So in that case, I should get the output, that is sum is equal to 1 and carry that should be equal to 0. Okay. Now let us have some another combination for this input. So I'll wait for some time. Okay, I'll minimize this time to 10 nanoseconds. Okay, then here I'll change this to A is equal to 0, B is equal to 1 and C is equal to 0. One more time. Now I'll make this as a 0, B also 0 and carry, that is 1. Okay. Now I'll make A and B both 1, carry 0. Just look how I am changing these values. Okay, so I have used almost all combinations here. So I have taken it as 001, then 010, okay, then 100, 011, 101, and 110 and 111. Okay, all combinations, because 000 already it is being considered while resetting this circuitry. Okay, so now okay, comment this, because again we have not used clock. Then wait, so that whatever is the last input condition, that will be restored, then end of the process and then end of the architecture. Okay, so save this, then select simulation, select the test bench which you are going to simulate, and then here you will find the iSim simulator. So expand this, check behavioral syntax. Once it is clear, correct, then click on simulate behavioral model. Now here, as I have taken time period, that is a small, okay, so that is a 10 nanosecond. For 10 nanosecond only one value will be restored. So this you can see as a this waveform that you can see for the small time. Okay, so first reset condition, that is a is equal to 0, B is equal to 0 and C is equal to 0. You get sum equal to 0 and carry, that is also equal to 0. Then here you will get for 100 combination, you will get sum 1, carry 0. Then for 010, sums 1, carry 0. Okay, and for the last, if I check for A, B and C, all 1 1, sum is 1 and carry is also 1. Okay, so this is the result. So that means here you can see that all the कंडिशन्स दॅट आर करेक्ट. तुम्ही जर कुठल्याही मधल्या कंडिशनला चेक केलं तरी तुमच्या लक्षात येईल की इथे A 0 आहे, B 1 and C in 1, so sum is 0 and carry that is equal to 1. So this is the verified that this whatever design that we have done, that is a correct one. Okay, so this is the test bench for full adder circuitry. Okay, so all of you got this? Anyone has doubt? Everyone understood?
No doubt, ma'am.
Okay. Okay. So let us stop here for today. On the next session, we will discuss some another circuitry. Okay. So for today, we'll stop here. You can leave this meeting. Okay. Bye.